Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Bazli. We are from section 1, group number 4. So the title for our project is the voltage sex problem on PV technology systems. So here's our group members, starting from Lionel, Jesson, Mohamad Rasyad, Ruzaini, me, Mohamad Aliff Bazli, Faris bin Nordin, and Nizamullah. So for the introduction part, this is our problem statement. So the problem statement is the voltage surge and voltage dips. The voltage surge or voltage dips is the decrease in the RMS voltage level to 10% to 19% of nominal at the power frequency for duration of half cycle to 1 minute. This can be associated with both fluctuations on voltage and with load turning on. The load sometimes having an errant current that trigger the voltage to dip, causing light to dim or equipment to trip offline. This is the example of the voltage surge. Okay, the objective here, there are three essential objectives here. The first one is to identify the power quality disturbance in the photovoltaic technology system. The second one is to implement the techniques in solving the disturbance that occurs on PV system. Last but not least is to be familiar with the generation of power quality disturbance and their respective mitigations. Okay, for the scopes, we are using the MATLAB software in identify the power quality disturbance and their respective mitigation. And we are covers the power quality categories with their relevance measurements.
Okay, next I'm going to present to you about the literature review of this project. Okay, there are plenty of previous studies that can be used as a reference and also comparison, especially the components involved and the methodology in order to make an improvised version of this system. The comparison is done for review purposes to implement some reasonable point from the previous studies into this project itself. The comparisons are including the design of the principles, simulation of project, and also the project analysis. Okay, without further ado, let's proceed to the content of this chapter. Okay, there are in total of 3 projects that are being reviewed, and the first project is the protection of grid-connected photovoltaic system during voltage sag. Okay, the second project is the mitigation of voltage sag and swell in a grid-connected PV system by using dynamic voltage restorer. And lastly, the last project is the voltage sag, swell and harmonics mitigation by solar photovoltaic fed ZSI based UPQC. This is the comparison of previous studies in the table form. Okay, we convert it into some components. I mean, there's some points that are that are similar to each of the projects. Okay, the first component is the software simulation. Okay, as you can see in the table here, all of the projects are using MATLAB Simulink software simulation to simulate the system, to produce testing and also the results via software simulation. And also the next component is the analysis method. Okay, the first project is using software simulation to produce the testing and also the results of the project, while the second project is using experimental testing, which is conducted in the lab and also being reviewed of the results by using observation and also testing by using devices and also electrical appliances, and lastly the last project is using software simulation, same as the first project. And lastly, the added feature in all of the project are the first project is it contains distribution feeder via a transformer, which is the 20 kilovolt in rating, while the second project contains DVR, which is used to detect missing voltage, and lastly the project 3 contain, it implemented of ZSI UPQC um, component in the project. Okay, I think it. This is it for the literature review of this project. Thank you.
Ya, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Rasyad Ruzaini bin Azmi. My metric card number DE180-200. So next I will explain about the methodology. Okay, for the theories applied, voltage sag indicate the decrease in the magnitude of the supply voltage. It typically less than a few seconds and has a duration of more than one cycle. This issue is defined as a total interruption or decrease in voltage or load current for a few milliseconds, 1 or 2 seconds. So this type of issue causes data processing equipment to malfunction. It may also result in data loss. So the quality of the power supply can be improved and the remaining effect on the supply can be mitigated in PV system by use of interfacing device with UPS such as a battery backup device. Okay, for the flowchart of simulation, we simulate and run the model, the design using the Proteus software, and we run and we show the output graph and satisfies of the output graph. If the graph got the voltage sag, we simulate and run the model again. So if no voltage sag, we proceed to analyze and record the output result and proceed to the end. Okay, this is the circuit without battery backup device. So by simulating the PV system with voltage sag, this circuit is designed with using Proteus software. So the PV array will convert sunlight to 12 volt DC and we through to the 555 timer circuit to represent an inverter, which is the inverter will convert to DC supply to AC supply. Then this is the transformer. The voltage will through transformer to step up the voltage up to 230 volts AC load. Okay, this is for the circuit with battery backup device, which is the circuit made to overcome the voltage sag. So the battery backup device in circuit as a backup supply to the load. The PV array will convert sunlight to 12 volt DC and through the inverter and also through the battery for charging the battery.
My name is Nizamullah bin Mahmud. I will continue the presentations about the result analysis. Okay, our simulations was run on Proteus. So this is the results of waveform for voltage sags. The result of simulation was taken for about 220 milliseconds, and the sags voltage are into cycle where the RMS value is around 198 volts. Okay, the most affected reasons is when this load is turned on, it will enrush the current, which trigger the voltage to dip. Okay, so to mitigate this problem, a solution is need to be proposed. So the solutions can be taken to mitigate the sags voltage in solar system is by integrating this system with a backup supply, which like a battery. Okay, this integrated system will mitigate the voltage sags by supplying the load using the stored energy in the battery. So upon the detections of voltage sags, the load is transferred from the main supply to the secondary supply, which is the battery. Okay, the sags problem is available after the battery is installations, as you can see in the graph, the waveform of voltage after battery installed. Okay, this technique is called as an uninterrupted power supply, and there is three configurations in the UPS technology, which is online UPS, standby UPS, and hybrid UPS. Okay, the next part will be continued by my team members, which is Faris. Thank you. Hello doctor, I will demonstrate our simulation in observing the set voltage characteristic in standalone PV system. So here is our simulations where the first circuit is without backup supply and the other circuits have a backup supply which is battery. Voltage graph for the circuit without backup show the waveforms of voltage sags, while the outputs of voltage graph without battery show the voltage has been avoided. The voltage sags has been avoidable. So here the sags voltage is happen for 2 cycle where the where the RMS value is 191 volt. So while the stack problem in the stack problem in standalone is being solved by connected the battery. So here graph show the RMS voltage is in normal range, which is 212 volt RMS. And that's all.
My name is Faris bin Nordin. I'm going to present part conclusion. So the overall from the project, all of the objectives were achieved in terms of identification of the power quality disturbance in the photovoltaic technologies as shown the result in a AC waveform before mitigation applied. In this project, we use UPS system as a mitigation in this project to overcome the problem from the disturbance based on the graph result. Next is Proteus software is used as an element finite solver, the disturbance and to overcome the disturbance occur on the PV system. So last but not least, in this subject also we can learn more about the generation and UPS system on the subject of a power quality system, disturbance and their respective mitigation. So for the part recommendation, our group will suggest that the PV will be applied to the circuit, truly monitor and observe the power quality problem caused by it. And this can be implementation of precise and exact solution to the power quality problem. So that's all from us. Thank you.